Missing person problem occurs during Amber Alerts, prison escapes, or while looking for missing children, senior, or a potential person of interest. In all cases, authorities always have a physical description of the missing person, as we can see in these flyers. For example, a 13-year-old white male with medium build, wearing a blue hoodie, a sleeveless jacket, and blue jeans was last seen on 17 October. The investigation process is complex and often requires a long time. Authorities often starts with surveillance footage, public tips or tweets, and previous case reports. Surveillance footage can include CCTV videos, dash cam videos, and in-store videos. Whenever there is a 911 call, event reports and incident reports are generated by authorities. Press releases help to circulate the information to public knowledge, whereas tips from general public are collected through hotlines and tweets. This investigation process entails manually going through a large number of video feeds. Police officers have to manually find out similar cases if abduction or crime is involved. They have to rely on human capabilities to figure out the same features through many different data sources. This is a difficult, manual process that requires sifting through different data for many hours on a whiteboard, and even worse, not finding the person in time to save them. My name is KMA Solaiman, and we would like to introduce Find Them, which is a system built for optimizing the investigation process, allowing involved authorities to easily analyze different data sources and be able to connect them for finding missing persons based on the desired features in an efficient manner. When building Find Them, we had several goals in mind. First and foremost, we wanted to fuse data sources by integrating features from heterogeneous sources in a way that enables automated investigations for a missing person. We need to be able to support large scale of data sources with large amount of streaming or historical data. Find Them would be put in practice in West Lafayette for connecting data about a missing person. Let's walk through a quick demo of our user interface. Imagine you are looking for a missing person. You have a flyer with their physical description. You have two options when you use the system to find them. You can either upload the flyer to the system as an example to find out similar documents or video feeds, or you can enter the physical descriptions to create an incident in the system to find out similar documents, tweets, or video feeds. First, we will upload a document with the physical description as an example. You need to select the time range that you are interested in to search for. And then we can see down below we have two available camera feeds as indicated by the yellow icons on the map. If we want to search the area around both the feeds, we will have to select the surrounding region. Let's see what we have got. Immediately we got relevant results similar to the provided example. On the right-hand side, we can see the video clips in the documents that has the person with red upper clothes and black bottom clothes. For creating the incidents, along with the date range and region, you have to enter the description of the missing person. We can see that there are multimodal results on the right-hand side, videos, and documents. You can see the document icons, you can download them for circulating. We can also have results only for singular modality, as we can see for this incident, it is just documents. And as time passes and new relevant data comes in, it is delivered to the user in real time. So, the elaborative investigation process before would only be a few steps now. Find Them eases up the missing person search by eliminating the task of manual lookup. This helps to track the missing person and relevant information about him in time. Find Them has a four-stage architecture. First, it takes all incoming and streaming data, converts into a singular format for each modality, applies pre-processing, and stores them in our database. We call this module data capture and storage. Then we apply machine learning, natural language processing and heuristic-based models on the clean data. We call this stage feature identification. Upon user input or user example, during data fusion, we create the query using the data description language and create a fused subset from the current data. Lastly, we go back to the user query and return the relevant results and wait for triggers in the streaming data. We wanted to highlight a few of the primary features in Find Them. Heterogeneous data ingestion system allows for scalability and real-time analysis. We applied different feature identification techniques depending on different context and different data modality. Data fusion using the relational queries helps us scale to petabytes of data and allows to produce situational result in time. Find Them has the capability to fulfill user needs over time if complete analysis or data is not available right away. Finally, Find Them has a user interface which is easy to use for everyone, technical or non-technical. Find Them has a data capture system for video feeds and tweets, along with a compatibility feature to process historical data and tweets. The high-level feature identification allows a real-time analysis for most modalities. Storing both the raw and processed data in RDBMS allows scaling to a large amount of data and sources. When we investigated missing person descriptions, we found over 15 different features that are commonly described, such as gender, race, clothing color, build. We experimented with many different techniques. For video feeds, machine learning is very general but requires a lot of data, whereas a heuristic method like color sampling works well for cloth colors but is very situational. For text, we used a combination of natural language analysis techniques and heuristic methods. We found out this heuristic methods works well for any object attributes and could be used for other objects with minimal modification. For data fusion, we built an entity-attribute relationship model for the missing person application domain. This was built based on the physical descriptions in the text documents. Each modality of data has to follow this schema and store the extracted features in Postgres using this schema. Upon receiving an example data object from user, we employ the same feature identification as server-side and create a query using those features as predicate. At this point, different tables contain features from different modality. Finally, fusing multimodal data consists of creating join queries among different tables on the user-provided features. This ensures a single information model for data representation, so we can scale to any number of data sources as long as features are extracted from them. This is a simple plug-and-play functionality to Find Them. Extending Find Them to other modalities may require extending the schema, but it can scale to any number of modalities without change in core functionality. We have used the trigger functionalities shown in Hilda paper in our Postgres insertions. When an initial query is posed, our current dataset may not have the desired result of the user. But we return the existing single modality result to the user. Then, when any relevant data from other modality streams into Find Them, we immediately trigger it and send the data to the user with notifications. This allows us to complete user need over time. We built Find Them with ease of use in our mind. Using our user interface does not require any technical training, and the results are presented in a way that the user can understand them easily. User can either upload desired features they are looking for, or they can upload an example data. The returned result can be unimodal or multimodal. Easily understandable icons differentiate between different results and allows user to circulate information among them. We can improve Find Them in many ways. First, we are working on adding more models to our feature identification module, such as running, smoking, or tattoos. We are experimenting to integrate complex modalities, such as LiDAR, to Find Them. We have plans to expand the current data modalities that we use with more information sources like BMV records, body cams, or city records. Finally, we are working on expanding the feature extraction and relevance modeling module by building it into an end-to-end training model. This would allow us to generalize to more application domains without supervision while scaling to any number of modalities.